customer required an instrumentation system which would be used to monitor the surrounding conditions within the trailer. Several parameters can be measured, such as humidity, temperature, moisture, light, and CO2 levels. In addition to that, the customer also required us to do some research on pH and electrical conductivity sensors, which can be used to measure the nutrient concentrations in the water tray. On the slide shows the base station and the sensor nodes. The sensor nodes are placed on each of the trays within the trailer. It consists of a microcontroller which is connected to various sensors such as CO2, moisture, ambient humidity and temperature, and soil temperature. It also provides a method of storing information from the sensors onto an SD card. It is also able to send information to the base station via a wireless link, which is Bluetooth Low Energy. We had thought that we would incorporate a power management system comprising of a battery and solar cell. However, because a battery power system provided the requirements which we needed, we decided to stick with just a battery. Each of the sensor nodes consists of a RFID tag. The base station, on the other hand, receives the wireless uplink from the sensor node, contains a RFID receiver which is able to detect the presence of RFID tags, and also connected to the pH and EC sensors. I would like to go into more detail on the specifics of the sensor node design. The microprocessor, which was Arduino based, was chosen because of its low power capability and also because it provided plenty of inputs, which is necessary as we would be attaching many sensors to the device. The main parameter which was used to select the various sensor nodes was the power consumption of each device. In addition to that, Bluetooth was chosen because it provided the most low power solution in the current wireless technology market, outperforming the likes of Zigbee and Wi-Fi. A power supply was chosen consisting of 4 AA batteries. As mentioned previously, power management is the most important aspect which was considered when designing the sensor node. The CO2 sensor consumes a lot of power, and therefore a transistor was included in the design so that it would allow the CO2 sensor to be switched on and off depending on the user's requirements. Due to the power consumption of the CO2 sensor, we decided to produce two versions of the sensor node, one without a CO2 sensor and one with it. The one without a CO2 sensor could incorporate a battery with a longer lifetime. Moving on to the base station. The base station is based on the Raspberry Pi architecture, which is readily available and quite cheap. The Raspberry Pi was chosen above other options because it allows data to be managed very easily, and because our system consists of various sensor nodes talking to one base station, it was very important that the base station is able to handle this data. It is connected to the NFC reader, which is used to measure the position of the trays within the system. The base station receives the data sent by the sensor nodes via Bluetooth. This information is then stored and easily visualized using the platform which we have provided. This is explained in greater detail by my teammate Shayu.